In my room, we have light bulbs. Specifically, we have 40 light bulbs. No way. Did they change it? Huh. I used to have half as many light bulbs as I have now. They've doubled them. There used to only be 2. Okay, well there you go. It changes it completely. That's funny. It's changed from last year. Okay, here we go. We have in each one of these sets of light bulbs, there are 4 light bulbs. How many sets of light bulbs are there? 20 sets of light bulbs for a grand total of 80 light bulbs. There are 80 light bulbs in my room. Each of these light bulbs is rated at 32 watts. When you live in the United States, you have outlets, and there is a standard electric potential difference across these outlets. Does anyone know what it is?
20.
Yes, Shaswini? It is not 110, Jay. 120 volts. It is 120 volts. A lot of your power converters actually will say 110 or 115. This is left over from, I believe, the 1950s or 1960s, which is just amazes me that there was a standard made in the 1960s, I believe it was 1960s, and we haven't upped the power converters for some reason. They just continued to say 110 on them, even though it's wrong. They actually are 120. Anyway, so 120 volts is the electric potential difference in the United States if you're talking about a standard household appliance plugging anything into the wall. So your air conditioners, etc., work off of 240. We're not going to go through exactly why that is. If you live in Europe, for example, instead, everything is built based off of 220 volts. All right. Let's see. So we have that information. Now, I generally get here around 6:50 in the morning. Sometimes I get here a little bit earlier. Sometimes I get here a little bit later. The other day it took me an hour to get to school, so I got here a lot later, but that's okay. Generally on Monday through Thursday, I leave somewhere around 3 or 3:05. On Fridays, I leave around 2:16 when you guys leave. Which means Monday through Thursday, I'm here slightly more than 8 hours each day, and on Friday, I'm here slightly less. So let's take an average of 8 hours. In other words, the light bulbs in my room are on an average of 8 hours per school day. Bless you. I generally pay about 12 to 13 cents per kilowatt hour. That's what the electric company charges me. We're going to assume that the school district gets a deal. I don't know exactly what the school district pays, but we're going to assume that the school district pays 10 cents per kilowatt hour. And I want to know 2 things. Part A, what is the resistance of these light bulbs? Part B, how much does it cost to run my light bulbs for a day for the school district? Let's start with resistance. The resistance of one of these light bulbs. How are we going to figure out the resistance of one of these light bulbs? Lawrence, thoughts?
We have the resistance equals electric potential difference over current.
Which of those 3 do we have?
None of them.
Well, we have electric potential difference,
Yeah.
right? That's the only ones. We don't have enough to use that equation to figure it out. So not going to get there using electric potential difference equals current times resistance. Instead, Hamza?
Power equals squared over resistance.
We can use, because we know the power, we know the electric potential difference, we're trying to find the resistance, we can use the fact that power equals the electric potential difference squared divided by the resistance. In other words, resistance equals the electric potential difference squared divided by the power. Resistance equals 120 volts squared divided by the power, which is 32 watts. The resistance of these light bulbs, please. I'm sorry, take it?
450.
450. 450 what, Josh? Ohms. What's the symbol for ohms, Simone? Don't point. Tell me what it is.
The capital Omega.
The capital Omega, or Andrea?
The unlucky horseshoe.
You can call it whatever you want, either one, as long as you remember what it is. 450 ohms. Good. Now, we're going to figure out how much it costs the school district to light my room for an 8-hour day. And just, you know, this is a fun game you could play at home because, for example, on the back of my monitor, it does say that this uses 1.5 amps, which is information you could use to figure it out. On the back of this TV, it says 219 watts. On your electrical appliances, it's supposed to list the amount of energy it uses somehow, either giving you the number of watts or the current. These laptops, for example, use 1.7 amps when they are plugged in. We are going to figure out how much it costs. We have all the information we need on the board. How would you like to start? Austin, thoughts? 80 light bulbs, 32 watts. We have electric temperature difference. We know it's 8 hours per day. We know 10 cents per kilowatt hour. Anything.
Not a clue.
Come on, give me something. We know, how about this? We know there are 80 light bulbs. We know each light bulb uses 32 watts. What can you use that for?
Well, you can times 32 by 80.
To get what?
How many watts there are total?
This is the total power. So the total power is equal to 80 times 32. Please?
2,560
2,560
watts.
watts. In other words, right now, in this room, there are 2,560 joules of energy every second being converted into heat, light, and sound simply due to the light bulbs. Okay, that's the total power. Sarah? Okay, let's convert it to kilowatts. We know we have 2,560 watts. I'll do this conversion. We have 1,000 watts on the bottom. We have 1 kilowatt on the top. We get 2.56 kilowatts. Okay? We're using 2.56 kilojoules of energy every second. Jay?
Convert 8 hours to seconds.
We actually don't need to convert 8 hours to seconds because, I agree, normally we would, but notice that we pay per kilowatt hour. So what we actually need to figure out is the number of kilowatt hours we use. And in a little bit, we'll make sure you understand what a kilowatt hour is. We're not going to do that just yet. But we pay 10 cents per kilowatt hour. So our goal here is to figure out the number of kilowatt hours we use per day.
You just times it by 8.
We multiply the kilowatts by hours, we'll get kilowatt hours. If we take our 2.56 kilowatts, we multiply it by our 8 hours per day, we're going to get, whatever we get, what's the number, please?
20.48.
I'm sorry, say it?
20.48.
20.48. 20.48 kilowatt hours per day. 20.48 kilowatt hours per day. We're close. We want to know how much it costs per day. Akbar,
Multiply that by 10 cents
per kilowatt hour. If we take our 20.48 kilowatt hours per day, we multiply that by the 10 cents per day, or per kilowatt hour. Kilowatt hours cancel out, and we get $2.048 per day. With sig figs, we'll just go with 2. So $2 per day. That is how much the school district pays to light my classroom for a school day. $2 a day. How much does it cost the school district if I forget to turn off my lights and they're on the whole time that I'm gone?
$60.
$4, right? Because it's only 16 hours that I'll be gone. If it's over the weekend, it's going to be a heck of a lot more. How many classrooms in the district? I don't know. But it proposes an interesting number, $2 a day. Okay. What's a kilowatt hour? Oh, no, actually, before we do that, I want to point out this. The most common mistake with this particular problem is to assume that there are how many hours in a day? There are 24 hours in a day. Yet, on the board, I have 8 hours equals 1 day. It's right here. Explain. How can I say there are 8 hours in a day, Knickerbocker? I don't know either. Gosh. Would you agree that could be confusing for students?
Yes.
So this is important to realize. Why am I saying there are 8 hours in a day? Lawrence?
The lights are only on for 8 hours.
Because the appliance, whatever it is, in this case the lights, are only on for 8 hours a day. So when we talk about, for example, there'll be a problem, I'm sure, on your worksheet where you talk about how often your TV is on, just for fun. And so the TV isn't, I hope, on 24 hours a day, right? So when we're talking about the number of hours in a day, what we're talking about is how much that appliance is on per day.